okay? But they've been upgraded, the computers and everything that's behind them. Beneath us is a room, it's called the logic room. So out here in the plant, there's 11,000 data points that's being fed into here, okay? Temperatures, pressures, levels, flows, okay? Those are all being fed through this data cards and then through processors, through a computer, and coming into here. So on here, if it's in red, it's in alarm, and it would be on one of these alarm lists. Of course, those are going to be buried way under here. There's probably 500 alarms in here right now, been tower shut down, okay? If it's in blue, it's good. We like that. This is an example of a pump. So we have these pumps here. If we started that pump, it would start blinking. It would blink red and then turn solid red when it was up to speed, okay? And then we monitor the flow. We have valves that control the flow, and we pump it up into the boiler, okay? Just an example, every power plant has different styles of graphics, whatever they like. Our power plant in Craig just got brand new controls. Their graphics look totally different to ours. We like ours. It's what we've been using for 32 years, so we're comfortable with them. This is an example of the boiler. We said the coal's burning inside the boiler. Well, the boiler is really two separate combustors. So there's two separate chambers, 20 foot by 20 foot by 110 foot tall. And the reason for that is velocities. In order for the circulating fluid dyes bed to work, you got to have a certain velocities to lift that sand. And this is one of the problems that they couldn't scale the technology up, was they couldn't get a big enough vessel to boil enough water and plus keep the velocities up. But anyway, here again we see damper positions, temperatures, we have airflows, the oxygen in the atmosphere, 21%. Okay, when we're actually combusting, this will be clear down to 2 to 3%. We're burning that oxygen out of the atmosphere. So when it goes out the stack, it's only 2 to 3%. Okay? Kind of a little side note here. There was a power plant. It was the next one in line after they built this one. The news helicopter, they were starting the power plant up. So the news helicopter says, let's get a picture down the smokestack. Great idea, right? They fly over the stack, looking down in it. Well, what is the atmosphere coming out of that stack? It's only 2% oxygen. The turbine engines on the helicopter flamed out. They went crashing down into the parking lot. Didn't kill them. They bounced off a couple of car roofs and everything, but just a kind of a interesting side note there. Okay? So in here we're monitoring. This system will do probably 80% of the stuff in automatic once it's all up and running. We get it up and running manually pretty much. We touch everything. Once it's up and running, then we kind of put everything in automatic, and we have a set point, and it goes to that set point. About 20% of the stuff we still operate manually the whole time. So this is manned 24/7. There's someone sitting here all day long, and they're monitoring all these. There's 100 and some graphics. We utilize probably about 20 to 25 graphics on a normal basis. So they're monitoring these graphics, making sure everything is working correctly. We have the ring down phone. This is where they call us from over the hill and say, hey, we need you to go up on load, go down on load. Okay? This section over here is pretty much from the 1988. We haven't upgraded it. But these are the manual. This is the generator breaker that when I want to make that generator go online, I have to meet all these criteria. Then I can hit the button, it goes online, or I hit the button, take it offline, just like a light switch in your house. Okay? But there's logic behind it. It has to meet this criteria, this criteria. It's got to be the right voltage, the right frequency, all kinds of things. The speed of the machine, everything plays into that. Okay?
So